Okay, welcome back to CS232. Today we're going to be going over more of C# basics, arrays, enumerations, and methods. Methods might end up being in a separate video, so please be sure to check the news section and I'll let you know if I was able to fit onto this video or not. Alright, so starting in the start here, we're going to talk about arrays. This is going from Whitaker, chapter 13, 14, and 15. So arrays, you've probably come to know what these are, but just in case, just a quick review. Arrays are basically a list, ordering of things. It's a great way to keep track of a group of related things in programming. It's sort of just a assortment of things that are kept in some kind of sequential ordering or partially ordered list or something like that. It's basically a list. So from the aspect of games, for example, because that's been kind of our running analogy, let's say we were creating a menu system for a high scoreboard for a game. Well, if we were doing that, we'd have, say, 10 spots on the board, and each of those spots would represent one of the high scores. If we didn't have arrays, we would have to do something like int score 1 equals 100, int score 2 equals 95, int score 3 equals 92, and we would have to keep going all the way up to 10. This gets pretty cumbersome because, well, for one, we have to create all those variable names, all those separate variable names, and for two, we can't just iterate through that whole list. We would have to reference them as score 1, score 2, score 3, and so on. So it's pretty impossible to do any type of serious programming unless you have arrays. Arrays make much more complex programming possible. And here we get into how you create an array. Now, if you want to create an array, you just take basically you say int scores equals new int, and you have to have the empty bracket sign. So, for example, if I was going to create an array in my Xamarin project here, here's my Hello World project. I just made a quick project for this. To say int with the empty bracket scores new scores, I'm sorry, new int, and the size. And I can access it like this. I can say scores of 0 equals 100, scores of 1 equals 92, for example, or 93. And then I can say console.writeLine top score is, I can say plus scores of 0. This should do the trick. So this should give us what we'd expect is this would print out the number 100. Top score is 100. Just going to build this and continue here. And you can see that output as top score is 100. So that is how you access arrays. It's basically just a list. For example, here's a list that I just quickly created, 99, 92, 80. Obviously, these are all ordered by decreasing score, but that is something that you have to do for yourself. It's not like when you insert into an array, it just automatically sorts itself. You need to be able to keep track of that sorting on your own. So when we're getting at stuff in an array, as I said, you could use bracket notation like score 0 equals 99. That shows the first position in the array. Keep in mind that array positions start at 0, so the first element is always at 0. The second element is always at scores of 1. So in computer science, that's a standard way of doing it. So for example, when you saw my Xamarin program here, this 100 represents the first element in the list. This represents the second element in the list. That's sort of just a standard way of doing things. It's mainly because You can find the address of any position in this array by using this formula. Address equals base plus index times size. So for example, if your base is 0 and your index is, for example, 0, and you can multiply that by the size. In this case, the size is 1 because it's one number. So its address equals 0. If you instead have an index of 1, your base would be 0 plus 1 times 1. If your index is 2, it would be 0 plus 2 times 1, and so on. So anytime the base is really the starting point of the array. Now, if we were to use 1 as our starting point, it would be a little bit different because we would say that base would be 1 and index would be 0 times 1, for example, and then our address ends up being 1 even though our address is actually supposed to be 0. So the math works out nicely. Given this equation, address equals base plus index times size. Here's a couple other ways to create new arrays. Here we see int bracket bracket scores equals new int 10, and then we've got a whole list of possible scores. We see another way here saying int scores equals new int, and then all of these scores. So basically you do not need to put the number that you plan on putting in the array inside the brackets when you say new int. It'll automatically size that array to be however many numbers you put in it. So that's kind of nice. Quite often, especially when you're doing for loops on an array, you'll need to get the length of an array. So to get that, you say dot length. So, for example, there are however many things in an array. We would say scores dot length to get that length out. That's useful when you're doing for loops, but you could even use it in situations like this, like I'm showing here. If I wanted to print out console.writeLine length array is, I'm going to print out scores length. So I'm expecting 2 here to be my answer. In other words, length of array should be 2. Just to give you a heads up on the current problem I'm running into is I'm getting this error message. It's kind of a good teaching moment because this error message is basically saying I've got 2 errors here that say error could not copy October6 test.exe to bin/debug October6.test.exe failed. It says the process cannot find the file because it is being used by another process. So that means our previous debug session is unfortunately still running, and we need to find that debug session and destroy it. So to do that, you can hit Control-Alt-Delete, bring up your task manager, and look for the program name. And sure enough, there it is, October6 test. So I want to end process on that. And now try it again. So that might actually end up happening to you as well. So now we build it, run it, and indeed we say that length of array is 10. The reason it's 10 is because we size 2. I was wrong because basically I had thought that we just declared this to be of open size, but instead we declared this to be of size 10. So keep in mind that it will create that many positions for you in your array, whether or not you actually output them. Now that brings up a good question. What do you suppose we're going to get if we say console.writeLine position 2 is scores 2? We should get 0 in that position because 0 is the default integer value. And there we go, we got 0. So that's what I was expecting there. Now, if we wanted to make this work the way I showed you before, in theory we could do this. However, we're going to run into a problem in doing this. And I'll let you kind of think about what that problem is as I go. That's right, we don't have a size for our integer array. Integer arrays are not dynamically sized, so we have to put 10 in here. If we put 2 in here, we're going to run into a different problem. The problem we're going to run into is, of course, that here we're accessing scores of 2, but there's only 0, 1, 0 and 1 are the only valid positions in this array. So if we do a build on this, you're going to see that it's successful. However, when we run it, we're going to run into problems. And here we go, system index out of range exception. So we've got an out of range exception because we access the scores 2 position. So that might happen to you when you're programming. That just means you have accessed a position outside of the array, and you should check for that before you access it. Standardly, what people will do then is they'll put an if statement around this. So they'll write something like if scores dot length is less than say our position that we're trying to print is here. I'm going to change this to an int. So I can say int position is 2. So only if it's less than the position is that a valid statement to do. So that's a common error checking thing that people do in coding as well. Now it will skip over that. It will also not print my position 2. Because it's basically skipped over that entire statement. Okay, so moving on. Here's some common array algorithms. I'm just going to kind of go through these pretty quickly. This one is to find the minimum value in an array. So if you think about this, we've got an array here, 4, 51, -7, 13, 99. Hold on one second. All right. 99, -99, 15, 8, -8, 45, and 90. So we're going to go through all of these and find the minimum. And we're going to start out very high. I kind of showed you this earlier on in one of the other videos. We're going to start out at the max value for the int. And then when we go through this, the next one we find should be less than that current minimum. So the next one when we find, we go in this for loop. We go from 0 through the length. So we go at 0, 1, 2, 3, 4, 5, 6, 7, and 8. So if array 0 is less than current minimum, and indeed it is, it's less than max value, the current minimum is 4. Next we go in here and test array of 1. If that's less than current minimum of 4, no it's not. If array 2, which is -7, is less than the current minimum, well it is. So we say -7. We do the same thing for 13. -99 is less than the current minimum, so we reset that. We do the same thing for 15, -8, 45, and 90. None of those are less than the current minimum. So now at this point we have the current minimum in memory, and we can print that out or do whatever we want with it. Here's one that finds the average value, and in this case, we outside of the for loop, we declare a total that we're going to be adding, like a running total that we're going to be adding every time it goes through this loop. So the first time it gets the number 4, adds it to the total, then the number 51 adds it to the total, then -7, then 13, 99, and then finally it prints what the total average is. Another thing you want to keep in mind is you can have a matrix, basically an array of arrays. Arrays can be of anything you want, bools, ints, strings, or your own object types. So if you have an array of array, we also know this is a matrix. Basically what you're saying is you have 2 brackets here. You have the row and the index within the row. So matrix of 0 equals new int of 4. This gives a row of size 4. Matrix 1 equals new events of size 5, gives a row of size 5, and so on. And this last line is accessing the second element in the third row of the array. So it accesses the third row of the array is 0, 1, and 2 is the third row. And then 0, 1, that's the second element, and it's setting that second element to 7. If you want a rectangular array, there's an easy way of doing that. You just put int bracket, comma, bracket, and that's just representing the x and y values are equal. And you say matrix equals new int 4, 4, and now you can declare that and use it as you normally do. Here's a simple thing that just prints out matrix. I'm going to actually do this one really quick here. I'm going to copy this in here just so you can see how this ends up looking. I'm going to print this out using Xamarin. So this is going to give us the array. So here you see 0, 0, 0, 0, 0, 0, 0, 0. And the reason for that is because we've made this new int array by size 4 by 4. So 1, 2, 3, 4, 1, 2, 3, 4. And each time we're writing out the row, it starts at the row, goes over the entire row, meaning it goes over each position inside that row, each column position inside that row, and prints it out, writes it again, and so on and so forth. Another easy thing to do is the for each loop. So this basically says for each int score and score. So it will basically, the score in this case will be the score here ends up being each time it goes through the loop it takes on a new value. So for example, I'm going to do a quick trace of this just so you can see an example of this in action. Okay, what I mean by trace is I'm going to put a breakpoint here. So it goes through each loop of this for each loop. I'm going to say start debugging. So it goes through here, and before it even executes that loop, it's going to stop on that position, and you see it stopped on that position. As a watch, I'm going to put in here score. Score is a current value. Is 0. Oh, Jen. He's okay. And anyway, in this case, you see score is 0, and then we're going to go through each loop here. Now score is going to get set to 1. It says evaluating here, but that should populate in a moment. My thing is frozen, so just hold on a second. So score is 0 for each of these because we have, this is the next time through the loops, this is like the third time through, and score is going to be 0 again. And if you look at your debug printout, it's going to show had the score 0, 0, and so on and so forth, and it's going to do that for each of the 10 positions in the array. So I'm just going to step through this here, and we'll see. And we should see 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so that's it for loops. We're going to move on to, or I'm sorry, for arrays. We're going to move on to enumerations in the next video.